In this lecture, let us discuss about water jet problem. So this water jet problem is a classic problem in artificial intelligence that mainly involves finding a way to measure specific amounts of water using two jugs. So that too with different capacities. So here the main goal is to reach a specific target amount of water in one of the jugs without exceeding its capacity. So it can be done by transferring water from one jug to another jug. Say, let us take one example. So here we are having two jugs. So one is having a capacity of 4 liters and the other one is a 3-liter one. So they don't have any measuring markers on it. So there is a pump which is used to fill the jugs with water. The task is how can you get exactly 2 liters of water into 4-liter jug. So goal is we need to fill this 4-liter water jug with 2 liters. Exactly 2 liters. Okay. And there is no constraint on 3-liter jug. So here the state is represented with x comma y, where x represents the quantity of water in this 4-liter jug and y represents quantity of water in 3-liter jug. And as this 4-liter jug is having capacity of 4 liters, so as x represents quantity of water in 4-liter jug, so we can take x values from 0 to 3, whereas, sorry, 0 to 4, whereas y, the second jug is having capacity of 3 liters. So we can take y value from 0 to 3. And coming to the start state, initially these jugs they don't have water. So initial value is 0, comma 0. So both jugs are empty. And the goal state is we need to fill exactly 2 liters of water in 4-liter jug, and there is no constraint on 3-liter jug. So you can have 1 liter, 2 liter, 3 liter. So in value can vary from 0 to 3. Now let us see the rules, production rules that are required in order to define the actions, so which are necessary to move from one state to another. So these are few production rules. Here the first one, if x comma y, if x less than y. So let us take two jugs which is having 4-liter capacity, and here the second jug is having 3-liter capacity. So this is represented with x and this is with y. So if x is less than 4, that means the water present in this 4-liter jug, if it is less than 4, then you can fill this jug completely. Say if it is having 2 liters of water, then you can fill remaining 2 liters also until this 4-liter jug is full. And there is no constraint on y. Say if y is less than 3, that means if it is having only 1 liter of water, 1 less than 3, right? So then you can fill remaining 2 liters of water, and you need to do that. So you need to fill the water into 3-liter jug until it reaches its maximum capacity. And there is no constraint on x. And the third rule is if x greater than 0, x minus d comma y. That means if x is having 2 liters of water, for example, then you need to pour some water, say 1 liter of water onto ground. And there is no constraint on y. And here, fourth rule, if y is greater than 0, say if this y is again having 2 liters of water, then you need to pour some water from 3-liter jug outside. So you can pour 1 liter water outside. Pour some water out of 3-liter jug. And the fifth rule is if x is greater than 0, then pour all the water from 4-liter jug. So in our previous case, we just poured only some water. Whereas here in the fifth rule, you need to pour this complete water, 2 liters of water outside. So you need to empty the 4-liter jug on ground. So there is nothing inside now. Similarly, the sixth one. Pour all the water from 3-liter jug outside and there is no constraint on X. So out of 2 liters of water, you need to pour all the water outside and there is nothing. So pour or empty the 3-liter jug on the ground. Seventh rule, if X plus Y is greater than or equal to 4, say, let us take 2 more jugs here. And assume that this 4-liter jug is having 2 liters of water and this 3-liter jug is having 3 liters water. So X plus Y means 2 plus 3. 2 plus 3 is 5, which is greater than or equal to 4. And Y value is 3 greater than 0. So in that case, pour water from 3-liter jug into 4-liter jug until 4-liter jug is full. So here you need to pour water from 3-liter jug to 4-liter jug until 4-liter jug is full. So it is already having 2 liters. So if you pour 2 more liters into this 4-liter jug, then this 3-liter jug contain only 1 liter water. Initially it is having 3. After doing this operation, it contains only 1 liter water. So you can write it as 4 minus X. Okay. So here X is nothing but 2. So 4 minus 2 means 2. And what is Y? So Y is 3. So 3 minus 2, it gives you 1. And what is this X? So here X means maximum capacity, because we are pouring water from 3-liter jug to 4-liter jug until 4-liter jug is full. That means 4-liter jug is having 4 liters of water. So this rule 8 is also same. Here you need to pour water from 4-liter jug into 3-liter jug until 3-liter jug is full. So here Y value should be 3. It is full. And you can write this as 3 minus Y, which is subtracted from X. So apply the same logic. And in the ninth case, take if X plus Y is less than or equal to 4. So till now we considered greater than condition. Now we need to take less than. So if it is less than or equal to 4 and Y greater than 0, then take this. Say it is having 2 liters of water and this is also having 2 liters of water. Now 2 plus 2 is 4. So 4 less than or equal to 4. And Y value is 2, which is greater than 0. In that case, you need to add 2 liters of water from 3-liter jug into 4-liter jug. That means pour all the water from 3-liter jug into 4-liter jug. So if you pour this, then earlier it is 2. And if you add 2, it will be 2 plus 2. That is X plus Y. And there is nothing in 3-liter jug. So it is now empty. So in the so if it is rule 10, that is X plus Y is less than or equal to 3 and X greater than 0, then you need to pour all the water from 4-liter jug to 3-liter jug. Now 11th rule, 0, 2. Say this is having 0 liters of water and this is having 2 liters. Now we need to pour 2-liter water from 3-liter jug into 4-liter jug. So if you pour this 2 liters, then it will be empty. So which is nothing but 2, 0. And this value will be 2, right? Now in the last rule, if 4-liter jug is having 2 liters of water and there is no constraint on Y, then you need to pour all the water from 4-liter jug into ground. You need to pour the water from 4-liter jug on the ground. So empty the 2 liters in the 4-liter jug on the ground and there is no constraint on Y. So that value will be 0, Y. Now, using these rules, let us solve the problem. So now our goal status, we need to get 2 comma y. This is our goal state. Initial state is 0 comma 0, right? So in the first case, we are taking this y value as 0, and this is our final state. So just take this condition. So initially we are starting with 0 comma 0, and now, so first we'll fill the 3-liter jug. So initially it is empty, and now we are filling this 3-liter jug with 3 liters of water, and there is nothing in 4-liter jug. So we are applying this rule 2 here. So what is rule 2? So we are filling this 3-liter jug with water, and there is nothing in 4-liter. There is no constraint on that. And after that, pour all the water from 3-liter jug into 4-liter jug. So here you need to pour the water from 3-liter jug to 4-liter jug. So that 4-liter jug, now it contains 3 liters, and 3-liter jug is empty. So we are applying rule 9 here. So what is rule 9? If x plus y is less than or equal to 4 and y greater than 0, then you need to pour all the water from 3-liter jug to 4-liter jug. Next. So now this jug is empty. So you need to pour water, 3 liters of water into 3-liter jug. So we are filling this water. So what is this rule? So there is no constraint on y, and if you fill 3-liter jug, then that is nothing but rule 2, same rule which we applied before. And after this, here pour water from 3-liter jug into 4-liter jug until 4-liter jug is full. So already this is having 3 liters of water. If you fill this 3-liter jug until it reaches its maximum capacity, then the water which is present in 3-liter jug is 2 liters only. And after this, so that is rule 7. And now our task is we need to pour all the water from 4-liter jug onto ground. So empty this 4-liter jug, so which becomes 0, and this 3-liter jug is remains the same. So this is rule 5. So when you empty or when you pour all the water from 4-liter jug onto ground, so that is nothing but rule 5. Next, our final state. So this is our target, right? So we need to pour water from 3-liter jug to 4-liter jug. So this 3-liter jug is already having 2 liters of water. If you pour it into 4-liter, you will get 2 comma 0. So this is our final state. So this is one way of solving this problem, and you can even take y value. So you can take y value as 0, 1, 2, 3. So as 3 is the maximum capacity. So let us try to solve in a different way. So here I am taking the maximum capacity 2, 3. That's a final state. So initially we'll start with the initial state 0, 0. And now first we are filling the 4-liter jug. And after that, so this is a 4-liter jug, and this is a 3-liter jug. So first we are filling with 4 liters of water, and there is nothing in 3-liter jug. After that, you need to pour water from 4-liter jug into 3-liter jug until this 3-liter jug is full. So we'll pour 3 liters of water here. So now it is having 3, and what is the capacity here? Now it will be 1. And after that, you need to pour all the water from 3-liter jug to ground. Now this is empty. So that is the state 1, 0. And after that, you need to pour the water from, so here pour water from 4-liter jug to 3-liter jug. Pour all the water. So we are having 1 liter capacity here. So if you pour this 1 liter water into 3-liter jug, then there is nothing in 4-liter jug. After that, you will fill this 4-liter jug with 4 liters of water, So when you do that, so now this is a case, right? So if you fill this 4-liter jug completely, now this 4-liter jug is having 4 liters of water, and our task is we should get 2 comma 3 as a final state. So you need to pour 2 liters of water from 4-liter jug, so that you'll get 2 here, and this is having 1 liter. So if you add 2 liters to it, you'll get 2 comma 3. So that's your final state.